Hi everyone. So in this video, we're continuing on with our overview of factoring, and we are specifically going to be talking about the AC method. It's a very versatile factoring method, and once you get the hang of it, your math careers will be a lot easier going forward with all the other classes you'll be taking. So let's talk a little bit about what it actually is. It's a method where you are trying to break down the bx, the linear term, into two separate terms so you can ultimately do some grouping and then factor out it that way. So as you can see here, we're breaking down the negative 10x into, in this case, negative 4x and negative 6x. Because if these added back together, you would have still gotten negative 10x. So it didn't actually change anything. We just broke it apart. And then you can see here, there's a couple other steps after we'll talk about. But ultimately, that's the goal. So let's look at an example. So these steps will always work, assuming that it's a factorable expression. The only one that's not necessarily required would be the first one, just because the GCF is sometimes 1. Also, it just really makes life easier, typically, if it's just a constant. So first thing that you want to do is, if there is a GCF greater than 1, factor it out. So in this case, the GCF was 1, but if you had something like 16x squared minus 20x plus 6, you could factor out the 2, and that would just make your the rest of the problem a little bit easier. All right, so now where this actually gets its name from is you're multiplying a and c to get AC. So in this case, remember, a is the coefficient of the x squared, b is c is the constant added. So we're looking for a times c, which is 24. All right, so now step 3, you're finding factors of AC that add up to b. So you can see here they go through all the lists: 1 times 24, 2 times 12, 3 times 8, 4 times 6, and then none of those work, right? However, because we have a positive here, we have positive 24, you can also get positive 24 by multiplying two negative numbers. So you can list the same things again, but just with them both being negative. And when you do that, you do find that negative 4 times negative 6 is negative 10. Well, it multiplies to be 24, and then it adds to negative 10. So we are then going to rewrite bx as two separate terms. So we're taking our bx, our negative 10x, and we're rewriting it using these two factors we just found. So we're breaking negative 10x into negative 4x minus 6x. It doesn't matter which one you write first. The only difference would be, see here, we have the 2x minus 1. Instead, if we wrote the negative 6x first, we would have gotten 4x minus 3 on the inside. That's the only difference. Doesn't matter. But as you can tell, see, if I still simplified it, I still would get my original expression. All right, so you're now going to factor out the GCF of the first two terms. So the GCF of 8x squared minus 4x. So the GCF of that is 4x. And then you're going to factor out the GCF of the last two terms. So the GCF of negative 6x plus 3. So in this case, we're deciding to factor out the negative 3. So that way, inside we have a 2x minus 1. You always want to try and make the x positive. It's a little bit easier to work with. Also, if you do this correctly, you'll see that the two things inside the parentheses are the same. So if you forgot to factor out a negative, it would just be different by a negative. But ultimately, if you do it right, they are the same. You're going to factor then the common binomial out. So these two are the same, right? 2x minus 1, 2x minus 1. You factor it out. So you're left with 2x minus 1, and then whatever was left will be the remaining factor. So we get the 4x minus 3. So ultimately, when I factor this using the AC method, I get the 8x squared minus 10x plus 3 factors to 2x minus 1, 4x minus 3. And then you can check that by just multiplying it back out, and ultimately you should get the same thing. So I hope that helps. Please let me know if you have any questions, and best of luck.